Okay, let's talk about angles. I have a definition here listed for you. An angle is made up of two rays that share a common endpoint called a vertex, the angle created by rotating one ray away from a fixed ray. The fixed ray is also called the initial side, and of course the rotated ray where you end is called the terminal side. So we can have positive angles, negative angles, and you could have a zero measure. So let's look at a few examples. First of all, a zero measure would be if you start with an initial side and you don't move at all. That means you've gone nowhere. That would be 0 degrees. So let's look at a more traditional example for the second one. So if we start with our initial side and we rotate counterclockwise, so let's make a 45-degree angle. I'm rotating counterclockwise. This is a positive 45-degree angle. Our vertex is right at the point, and our initial side started the one that's going straight to the right, and then we ended with our terminal side. The next example is when we have a negative angle. So if we start with our initial side and we rotate clockwise, this makes us a 45-degree angle, but it's negative because of the direction. Okay, let's talk about different ways to measure angles. So we have two different ways, one with degrees and one with radians. Let's talk about them both. So if we look at a circle and we talk about angles, in degrees, if we were to go half of the circle, well, of course, if we start at 0, we have 0 degrees right there. Okay, if we were to go half of the circle, if we went half like this, that is 180 degrees. And of course, if you continued on and went the full circle, that's a whole 360 degrees. So if we talk about radians, let's say we start at 0 again. If we go half of the circle over here to 180 degrees, that's the same thing as pi. And then if we continue the circle all the way around, 360 degrees is the same thing as 2 pi. So when we talk about radians usually has pi in the angle. So remember, half a circle is pi. The whole circle is 2 pi. So each rotation that you make around a complete circle, you're going a distance of 2 pi. So if you look at the top, I have 360 degrees is the same thing as 2 pi. 180 degrees is the same thing as pi. And then from doing a little bit of algebra to these two small equations, we get 1 degree is pi over 80 and 1 radian is 180 over pi degrees. We're going to use these in the next slide to help us convert from degrees to radians and radians to degrees. Okay, let's talk about converting from degrees to radian measure. So as I have listed at the top of the page, to convert from degrees to radians, you multiply simply by pi over 180. So if we look at 10 degrees, in example 1, we can take 10 degrees, multiply by pi over 180 degrees. And by doing this, it's conversions. Our goal here is that we want to get radians. So we want the degrees to disappear. So if you notice, we can cross out common factors. So in the top we have 10, we can take out a 10. That leaves 1. And if we divide out a 10 of 180, that leaves 18. And notice the degree signs have crossed out also, so we have no degrees. That leaves us, when we multiply it out, 1 times pi is pi. And on the bottom we have 18. So we have converted 10 degrees to pi over 18 radians. Okay, let's look at number 2. We have negative 150 degrees. If we want to convert that to radians, we need to multiply by pi over 180. Remember, pi represents radians and 180 represents degrees. So once we do that, let's see if there's anything that we can cancel. So in negative 150, we can take out a 10. That leaves us negative 15. And a 10 out of the bottom leaves 18. If we multiply this out, we get negative 15 pi over 18. Alright, and so from here, we still have a fraction that can be reduced, so we can take out a common 3. So if we take a 3 out, we get negative 5. And on the bottom, we get a 6. So our final answer is negative 5 pi over 6. Okay, now let's look at number 3. We're going to go the opposite direction. Let's convert from radians to degrees. So we know that pi over 4, anything with pi is radians. So our goal is to get rid of the radians. So we're going to multiply by 180 over pi. And this kind of also helps because our goal is with degrees, no degrees are going to have a pi in it. So we want the pi to disappear. And the way I have it set up, these pi's will disappear. And then with 4 and 180, those can cancel. We can take out a 4. If we take out a 4, that leaves 45. So at the end, we have a 45-degree angle. Okay, let's look at number 4. We have negative 13 pi over 18. And we want to convert. So once again, we're trying to get rid of the pi, and that helps us know which one to multiply by. We want to put pi in the denominator because our goal is for those 2 pi's to cross out. And 180 in the numerator. Remember, we're trying to convert 2 degrees, and whatever one you're trying to convert to is what you put in the numerator. So here, let's start canceling out. Our pi's can cross out. We can take an 18 out of the bottom and an 18 out of the top. That leaves us 10. And if we multiply this out, we have negative 13 times 10 is 130. And on the bottom, we have 1 times 1. So our final answer is negative 130 degrees.